Mr. Carlson, the science guy.
Miss Carlson, Miss Carlson, Miss Carlson, Miss Carlson, Miss Carlson, Miss Carlson.
Mr. Carlson, the science guy.
For this lesson, we're going to take a look at the variety of models we can use to represent some basics in chemistry. And so one of the most common types of atomic models we'll see is the one listed here in the bottom left, where you have these orbiting electrons showing motion around the nucleus of an atom. And remember, the nucleus of an atom will contain positively charged protons, neutral neutrons, so not a positive or negative charge. And then the surrounding electrons are constantly in motion. And so we use different types of models to work with different parts of chemistry. And so we're going to start looking at this type of model a little bit more closely when talking about the first 20 elements of the periodic table. And the reason is, when we work with a two-dimensional model like this, we can use the location of the electrons to identify what types of atoms we're dealing with. And then in the future, when we start talking about bonding of atoms to create molecules or compounds, these types of models where we can look at the location of the electrons is really valuable. And so just to get an idea of what's happening here, the electrons are found in different energy levels, okay? And so these rings we call energy levels, by which a certain number of electrons can fit. When each energy level fills up, the electrons, they start filling in outer shells. And the way it works is the first energy level here, it can contain 2 electrons. And once that energy level fills up, then the electrons will start filling in the next ring, the next outer ring. That outer ring, that second level, can contain 8 electrons. And so that's why we have 2 listed here, and then they start filling in that second layer afterwards. After 8 electrons fill up that second energy level, we have this third energy level here, where 8 electrons can also be filled. And then the fourth one, 2 electrons fill up that one. So it's not a continual number. It's not a pattern of any sorts. And so you really just have to memorize the number of electrons that fill in. Now, something strange happens after the 2 electrons here fill up this fourth energy level. And we don't really need to dive into that too much, but what happens is the next 8 electrons actually start fitting into this. They go back to the third energy level here. And so this third energy level, you will often see can contain many more electrons, but what happens first is we go 2 there, 8 there, 8 there, 2 there, and then the electrons start filling up this third level more, and then it continues to grow. But the reason we don't really need to pay too much attention to that is we're only going to focus on the first 20 elements, and that means that this 2882, you'll notice when we add those together, we get 20, which means we only really need to pay attention to this 2882 format at the 8th grade level, just to sort of introduce the periodic table. So when you get into high school and older grades and more advanced chemistry classes, you'll start looking at how when we go beyond 20 here, the electrons sort of do something a little bit more unique. So all that being said, just rely on the fact that it goes 2, 8, 8, 2 for the first, second, third, and fourth energy levels. And then I wanted to introduce or sort of show you guys this atomic model. Atomic model showing the fact that atoms are three-dimensional. All right, we're dealing with matter, which is anything that takes up space and has mass. And so electrons do, in fact, find themselves to be three-dimensional, even though so many of the models we use, like the ones we just saw, are two-dimensional models. But just keep in the back of your mind that an atom is three-dimensional. So when we talk about these energy levels, they're not, even though we see them as two dimensions, a flat surface, they're actually three-dimensional. So you can think of it more as a sphere, and the way that the elements, not the elements, the way the electrons are moving is sort of all over the place. It's not just sort of like an up and down or a left and right. They're moving in all sorts of directions, just like planets, orbiting different celestial bodies. It's not always just one direction. It depends on the motion of the actual objects we're talking about. So anyway, I just wanted you guys to see that think of it more as a three-dimensional process, even though when we draw them and we work with them, we work so much in 2 dimensions. Okay, so we'll spend some time identifying different atoms based on how many electrons are in which shells, and eventually this will lead to getting a better idea as to how different elements bond and why they bond in certain ways, and we'll look at valence electrons and things like that in more detail in future units. All right, so that was just a little bit about how we draw different models of the first 20 elements.